Yes, good evening. Yes. I think my screen is visible to everyone. Okay. So in differential equation, as we have discussed in the last class, whatever the topics we have left, one of the particular integral and another one is Cauchy-Euler equation. So before starting particular integral, okay, I have to just give you a small introduction what particular integral is. Okay, so first of all, let us consider a differential equation. There are, since we are only considering the differential equation of second order only, we are not considering the differential equation of a third or more order. Okay, so far we have considered the differential equation with constant coefficients. Constant coefficients. Okay, it means that suppose d2y dx2 plus p dy dx plus q into y is equal to suppose rx. Okay, here p and q are treated as constant. So whatever the rules we have learned last class. Okay, rules means it is the rule for finding the complementary function, the rules for finding the particular integral, what we will discuss today's class. Everything depends on this constant coefficient differential equation. Okay, now what is variable coefficient? Variable coefficient means this p and q are not constant, they are variable and is a function of x only. That is function of the independent variable x. Okay, as an example, I'm giving you the d2y dx2 plus suppose px, it becomes px dy dx plus qx into y is equal to rx, like this. So here these coefficients are variable and which varies over this independent variable x. Okay, so remember that the rules are only effective in case of constant coefficient differential equation. Okay, and not for variable coefficient differential equation. There are a particular type of rules for variable coefficients. We have to convert these variable coefficient equations to this constant coefficient, and then we can apply the rules. Okay, before converting the variable coefficient equation to this constant coefficient, we can't apply any rules. Okay, so I will discuss these things today also. Next thing, what is the necessity of pi or particular integral? So far we have learned about the suppose RHS, these Rx. In the yesterday, whatever the equations we have discussed about, this Rx, the right hand side is equal to 0. Okay, if any differential equation, whether it is constant coefficient or variable coefficient, if the right hand side is equal to 0, then it is called homogeneous. Okay, and if the right hand side is not equal to 0, it is called non-homogeneous equations. Pi or particular integral only is applicable for non-homogeneous equations, not for homogeneous equations. So in case of homogeneous equations, the only solution is CF, complementary function. That is the three rules what we have discussed in the last class. First one is roots are real and different. Second rule is roots are real and equal. And the third rule is roots are imaginary. So all these rules and are to find only CF or complementary function. And that will be the only solution if the right hand side is equal to 0, that is the equation is homogeneous. But if the equation is non-homogeneous, that is instead of 0 any function of x, it may be rx equal to the right hand side rx equal to sine x, maybe e to the power x, maybe cos x, or some algebraic function like x square plus x, like this. Okay, then there are, we have to find out pi, or it is called particular integral, what we will discuss in today's class. Okay, and the complete solution will be given as CF plus pi will give you the solution yx equal to, the solution will be CF plus pi. That is, first you have to find out the CF by considering the right hand side equal to 0, and then you have to find the pi only which is applicable for the RHS, if any RHS exists, and then we have to add this CF and pi which will give you the solution. Okay, but in case of gate examination there is a complete solution, that is CF and pi. Okay, there is a less chance to be occurred because this is a very large method. So only either there is CF finding or there is pi finding, but not together. So let's now talk about how many types of functions are there. So in particular integral, there are different kinds of functions we have to consider in RHS. So the functions are of different types. First type is exponential type. Okay. Second type is algebraic type, and third type is trigonometric type. Okay, there is another type which is the combination of trigonometric or exponential. Okay, that is the multiplication type. That is different issue. I will discuss it later. So Rx, right hand side, how many types of equations is possible? First type is exponential form. Second type, trigonometric. And the third one, it may be algebraic. Okay, or maybe multiplication of algebraic or the exponential, like this. It may be x into e to the power x, it may be x into sine x, or e to the power x into sine x, and so on. Okay, so these kinds of equations, main specifically these three types of equations are there, or exists. So now for the first type, we are first considering case 1, where the right hand side RHS, that is the function Rx, is considered as an exponential function which is e to the power ax. Okay, there are some rules to find out the pi, and you have to remember this. Okay, and these rules are, there are other method to find pi, but that is very difficult method and very lengthy. So we have to just remember very small and very easy rules to find out what is the pi. Okay, so first, please write it down. The case 1 where the RHS is e to the power ax, that is exponential form. Then the formula is this one. Okay, write this whole thing. Then I will discuss it by using an example. Please tell me if you are completed. Okay. Now, example. What is the PI of this one? Okay, what is the PI of this one? First of all, just write it down. These equations I already told you in the last class, that is ddx, you can consider it as capital D. Okay, d2 dx2, you can consider it as d square, and so on. Okay, so look at this ddx of, so if I consider this one, now dx dy dx, if ddx is considered as capital D, then dy dx is considered obviously d into y or dy. It is not into, it is an operator. Okay, similarly d2y dx2, we can write it as d square y. So this equation, it can be written as d square minus 5 of y is equal to e to the power x. Okay, now how to find pi? Okay, if you want to find CF, complementary function, then this right hand side should be equal to 0. That is t square minus 5 into y is equal to 0. Consider this differential equation and you can find the CF by using that rules. The find the root, that is, this means this is m square minus 5 equal to 0, and find the value of m. Okay, m equal to root over of plus minus 5. Okay, roots are different. Then what is the rules? So that will be the CF. But I'm not bothering about the CF today. I'm bothering about the PI today. So that is why to find PI, write it down like this. Look at this. How can we write it? Y is equals to what? If I write y, then y is equal to, how can I write it? I can write this like this, d square minus 5 of e to the power x. Can I write this? Okay, just if I imagine d square minus 5 into y, this is a multiplication there is, then y can be written as 1 by d square minus 5 of e to the power x. Do not write this e to the power x in the numerator term. Okay, so this is the pi. Do not write y is equals to this. This is simply write pi is equals to this one. Okay, and according to the formula, what is the formula? This is the d square minus 5. This is called f of d. It means function of d only. That is, this term doesn't contain any other thing other than d. So that is why fd in this formula is considered. Look at this fd. Okay, this fd is nothing but this d square minus 5. According to the rule, forget about this fd or whatever. First write down this one, pi is equals to 1 by d square minus 5 of e to the power x. Simply put d is equals to a. Simply put d is equal to a and nothing else. Okay, simply put d is equals to a. Now if I put d is equals to a, please write down in the chat box what is the value of a here. Look at this formula, e to the power ax. What is the value of a here? Yes, the value of a is 1, because e to the power ax, okay, here e to the power x is given. So obviously a is equals to 1. So we put d is equal to 1 and that will be the answer. Okay. So after putting d is equal to a, we are getting pi is equal to 1 by 1 square minus 5 into e to the power x. This is the pi. This means e to the power x divided by 1 minus 5 is equals to minus 4. This is the value of pi. Very easy. Very easy. Nothing is nothing. There is not no rocket science inside it. Very nice. Very nice and easy technique. to find out the pi, but you should remember the formula. Okay, second one. Now this one you will do this for me. Write down, find the pi and write down the answer in the chat box. Not defined. Okay, any other answer? Vijit also says not defined. Okay, if not defined case occurs, there is no pi like not defined. Obviously, there is a pi. But if after putting d is equals to a, not defined case occurs, then there is a rule to find out the pi. The rule is like this. First, we are going step by step. This equation can be written as d square minus 3d plus 2 of y is equal to e to the power x. So correspondingly, the pi will be 1 by d square minus 3d plus 2 of e to the power x. Now what is a? If we consider e to the power ax, obvious a is equal to here 1. Now we should put d is equals to 1. So if I put d is equals to 1 here, what we get? 1 square minus 3 into 1 plus 2. But we see that, you see, 3 plus 2 is equal to minus 1, and 1 it becomes 0. And denominator 0 means it is not defined. Okay, so what should you do in this case? Here we do not put d is equals to a directly in this function, directly here. If this kinds of case occurs, okay, very just listen to me very carefully. If this kinds of situation occurs, that is after putting d is equals to a, this becomes, the denominator becomes 0, we should take the derivative of this denominator part. No, not d square equal to 1. No, we should take the derivative of this denominator part. Okay, take the derivative of denominator part. It becomes 2d minus 3. Am I right? After taking this derivative, put an x in the numerator. This is the formula. Okay, again e to the power x. This and this will be equivalent. Now in this equation, put d is equals to a. Now if I put d is equals to a here, we are finding x into e to the power x by d is equals to a, so minus 1. So this is the pi. Anybody has any question? Anybody has any doubt to find pi?
So why PI can't be not defined?
Sorry?
Sir, why PI can't be not defined?
pi
Why you solve like this and not put the answer as not defined.
No, 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 no. This is PI. It is not in this case. Actually, this is not the way to find out the PI. Okay, this is just the formula. These formula are arrived. These formula are achieved by some other theorems, and that theorems is a particular. There is a particular method to find out the solving or to find out this PI. Actually, there is an integral method. Okay, that method is very large method. This is just a formula, just a trick to find. If I put a d is equals to 1 here in this case, it becomes not defined, but we have to find the pi. Okay, in if I follow this integral rule, obviously there should be some value of this integration, okay, to find the pi. But if we follow these rules, then this rules has this burden or this disadvantage that you do not, maybe there is some possibilities that is after putting d is equals to 1 you are not getting this pi, that is the denominator part, it becomes 0. In that case there is another formula or there is another theorem to find out or to reduce this denominator part into less degree polynomial equation of d, and this equation and this equation are actually equivalent. After putting x equal to 1 here we can get the pi. This is not the proper procedure to find out the PI. This is just a trick. And these tricks and these formulas are obtained by using the original method, and which has the solution. The original method, integration method, it has the solution. So if in this, after applying this method, if you don't have this, don't find the PI, or if the denominator part becomes 0, then apply this formula again to get the reduced degree equations of d. Okay, it may be also possible that is after reducing this equation, after putting d is equals to 1 and the denominator becomes 0, then you have to apply another derivative here, and the numerator part, it becomes x square divided by the derivative of this one. Then again you have to put d is equals to something. Okay, so remember that it cannot be. You have to find out the pi and you have to formula until and unless you are getting an answer. You have to follow these derivative rules. And one time derivative, it means the numerator will be multiplied with x. Second time derivative, it means it will be multiplied by x square. If second time derivative also fails, again take the third time derivative and the multiplied by x cube. And this process will be goes on. Okay, got my point? So for gate exam or any kind of this MCQ type of questions, it may be gate, maybe net, or maybe some other competitive exams, you should remember these kinds of tricks. Okay, original method is there obviously, but that method, it is very large and you have to follow some other derivative rules also, okay, which I cannot complete within this short period of time. Next, case 2, RHS or right hand side is any trigonometric function of x. Trigonometric function, it may be sin x or cos x. Other trigonometric function are just the function of sine and cos. If I consider tan, it is sine by cos. If I consider cot, it is cos by sine, or like this. But the basic trigonometric functions are sine and cos. Okay, so we are only considering sine x as cos x. Tan, cot, or something that will not be in MCQ exams because the method to solve this process are very large. In this case, what you should do? Just put d square is equal to minus a square. What is a? A is this one. In the previous case, we have considered e to the power ax. In this case, we will consider sine ax or cos ax. Okay. Simply put d square equal to minus a square. Remember, d square is equal to minus a square. Okay, minus sign should be there. Do not just omit or nullify this minus sign. So solve this problem for me and write the answer in the chat box. d2y dx2 minus 5y is equals to 3 sine 2x. Okay, I've got three answers. Anyone else? Okay, so let's find out the answer. After converting this equation with d function, and we are getting d square minus 5 of y is equal to 3 sine 2x. Okay, and what is pi? Pi formula is same, 1 by d square minus 5 of 3 sine 2x. Since 3 is a constant term, we can take this 3 outside of this equation. So it becomes 1 by 3 of 1 by d square minus 5 of sine 2x. So simply put 2 here. D square is equals to, look at this, d square is equals to, what is the formula? Minus a square. So a is equals to what? A is equals to 2. Minus a square equal to what? Minus 4. Minus a square equal to minus 4. So we will put here 1/3 into minus 4 minus 5 sine 2x is equal to 1/3 into sine 2x. Am I right? No, I'm wrong.
Denominator, so 3, it should be numerator.
Yes, yes. 3. 3. So it means minus 1 by 3 sine 2x. Okay, so this is the answer. Next, solve this one. Look at this. The right hand side is also cos 2x. So d square is equal to minus d square is equal to minus a square, but there is a dy dx term is there. Then what should we do? Okay, try this, then I will solve it. What if it is d cube? In case of dq, you can also put it as d square into d into d. Okay, this term. But d cube term, there is another way to solve this d cube term. Okay, there is a complex number way. Okay, you can convert this sine or cos as a complex part. Okay, that is e to the power ix minus e to the power minus ix divided by 2i. Okay, there is another part, real part or complex part. Okay, so that method can be obtained, but it is very large and hard method. In MCQ, d cube, d to the power 4, these kinds of solution, it is not possible to occur, but square is possibility. There is possibility, or there is a chances for this d square term, hardly, not a d cube or d4. That is very difficult. That is, the method is very large. Remember, there is many ways to find out pi, not a single way. These are the some tricks. Sometimes the tricks fails, and then you have to apply the either the original method or there are some other tricks. Okay, but the methods are very large. 2 by 1 plus 6 I into cos 2x. No, not like this. Okay, so let's find it out. First of all, this method, sorry, this equation, it can be written as d square plus 3d plus 5 of y to cos x. Look at this, how easy it is. Okay, there is a small trick. It is sometimes you have to apply your brain. 1 by, what is pi? Pi is equals to 1 by d square plus 3d plus 5 of 2 cos 2x. Okay, 2 can be taken outside, so I'm taking 2 outside. Cos 2x. So cos 2x means first we have to put d square is equal to minus a square. Okay, so a square means a is equals to 2 here. So it means d square, we have to put here minus of 4. Minus of 2 square means minus of 4. But we can't put anything in case of d, in the place of d. D should be as it is. So 2 into, after putting d square equal to minus, so it is minus 4. Minus 4 plus 5. So it becomes 3d of cos 2x. Now, the problem is now
Rationalize.
this, sorry, any doubt?
So can we do rationalize now?
Exactly, rationalize. Now we have to convert this one as d square, otherwise we can't put d square equal to minus a square. In case of sin x or cos x, only d square is applicable, but d cannot be applicable. We can't put anything instead of d. Only we have to put in case of d square. So obviously we have to rationalize this. So this is 3d plus 1. Okay, let's rationalize it. 3d minus 1 divided by 3d plus 1, 3d minus 1 cos 2x. Done. So now it becomes, so 3d minus 1 in the upside, and the downside it becomes 9d square minus 1 of cos 2x, and after that it becomes, now put d square equal to minus a square, it means minus 4. Minus 4 into 9 is minus 36, so it is minus 37. So minus 2 by 37. Okay, minus 2 by 37 into 3d minus 1 of cos 2x. Up to this step, any problem or any kind of doubt are you having? Any doubt or any problem up to this step? Okay. Next, in the next step, just simply minus 2 by 37, just multiply this. 3d of cos 2x minus cos 2x. Just multiply. Can you tell me d of cos 2x is equal to what? D of cos 2x is equals to what? Please write down in the chat box. D means what? Capital D is equals to, what is the operator? Capital D means ddx. Just we have learned capital D means ddx. Okay, so ddx means just it is a derivative of cos 2x, and derivative of cos 2x is minus sin 2x into 2. So minus 2 sin 2x. Okay, so just simply now put here minus 2 sin 2x minus cos 2x, that will be the answer. So this is equal to minus 2 by 37 into 3 into, means 3 into 2 equal to 6. Okay, it becomes minus 6. Minus 6 sin 2x minus cos 2x. This is the answer, PI. Any doubt? Did you understand? So these are the tricks. These cannot be defined by any books or anyone else. You have to follow your brain. You have to apply your brain to find out these kinds of things. You know that there is only d square part where we can just shift the value of d square. But if there is a d, we can't apply anything. So that is why if I rationalize this, so we can make it the denominator part as only in the function of d square. So rationalize it. And the numerator part, yes, there should be d, but if numerator part is it is d, then we can simply take the derivative. Numerator part, how many d's are there, we don't bother about it because capital D means only ddx, it means derivative. So we don't bother about the numerator part, we only bother about the denominator part. Okay, next one. If the right hand side, so now so far we have learned about e to the power ax exponential function, we have learned about sin x and cos ax, that is trigonometric function. Now we will learn if it is algebraic function or any polynomial in x, then what should be done. Okay, remember these two things, the formula, that is this is 1 minus x whole to the power minus 1 and 1 plus x whole to the power minus 1, this formula. Okay, these two formulas, there is binomial theorem formula, you should remember to solve this equation. Now one, I am solving it because without solving I can't make you
Sir, please show the previous slide, sir.
okay.
Okay, sir.
Okay. Okay, so look at this function. So just I am taking, okay, first I am doing it for x. X square, you will do this for me, x square. Now it becomes d square plus d plus 1 y is equal to x. Okay. So now the pi becomes okay. Simply write it down like this: 1 plus d square plus d of x whole to the power minus 1. Can I write it? 1 plus d square plus d whole to the power minus 1 of x. Okay, now always you have to, your target is to find out the form like this: 1 minus x or 1 plus x whole to the power minus 1 form. Okay, so 1 is already there. Look at this, 1 is already there. And if I can take this d square plus d, this term, as x, x means suppose it is capital X, not x, x is already there is x, this variable, so we should consider it as 1 plus suppose capital X or y, whatever, whole to the power minus 1 of x. Okay, now simply use this formula. So which formula is applicable here? The downward, this was because it is 1 plus, so 1 plus d whole to the power minus 1, this formula is applicable. So that is why we will apply the formula 1 plus x whole to the power minus 1 is 1 minus x plus x square minus x cube plus dot 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 of x. Done. Now this is an infinite series, this goes to infinity. So how many terms you should consider here? This depends on the power of this function, the right hand side function, the highest power. What is the highest power of this right hand side function? The highest power is 1, that is this is x to the power 1. If it is x to the power 1, you should take only, that is power 1 term. Power 1 term means this is x to the power 1 term. Only take these terms. If it is x square plus x plus 1, that is highest power is x square, suppose, then you should take 1 minus x plus x square. Okay, and so on. So it depends on the power, highest power of the polynomial, which is given in the right hand side. So since it is only x, the power is 1. So we should consider only the first two terms. That is 1 minus x of x. Okay, forget about the rest of the terms. These terms are not necessary. This is equal to 1 minus. Now what is the value of x? You have considered x, this one, d square plus d. Okay, write down. Okay, everybody says b is the right answer. So just solve this. D square plus 4d plus 3 pi. Okay, 3 is constant term, take it outside. 1 by d square plus 4d plus 3 of e to the power 2x. Now a is equals to 2 here, just put d is equal to a. So d is equals to a means it is 4, that is 2 square is equals to 4 plus 4 into 4 plus 3. Okay, so 16, 20, 23, it is got 3x, sorry 2x, 4 plus 3. What is the mistake?
Sir, 4 multiplied by 2.
3 1 by 4 t square is equals to 4 plus 4 into, sorry, 2. So 6, 10, 12, 15. 15 means 1 by 5. To the power B is the right answer. Yes. Okay, so this is the end of differential equations. Now we will we'll go to complex analysis, and whatever the complex, in case of complex, I have seen the problems generally from poles, complex integrations, residue finding, pole finding. Okay, so these kinds of problems. And in general, there is a very and simple problems of complex, that is the finding of modulus or whatever. A very less type of or examples I have got from the GATE chapter or GATE question paper. So first, let us start with complex analysis now. So you know complex number very well. A plus IB is a complex number where I is equals to root over of -1. Okay. In higher mathematics, this A plus IB form is not used. The form is used as A comma B, the ordered pair form. Okay. So ordered pair, it means this is called real part, this is called imaginary part. Okay. And the multiplication with I is called imaginary part, and which is not multiplied with I is called the real part. Okay. So if I say this is Z, then real part of Z, REZ, A, and IMZ, it means imaginary part of Z is equal to B. Next, modulus of a complex number is just mod of complex number A plus IB is equals to root over of A square plus B square. Okay, just like the vector and nothing else. Next, which is most important part, function of complex variable. What is function of complex variable? It can be written in this form: uxy plus I into vxy. Okay, I'm giving you some example of complex variable. It is like this. Suppose fz, I am writing fz a complex function x plus y plus I into x square plus y square. This becomes a complex function. Look at this, it can be expressed as u of x comma y plus I into v of x comma y. Okay, uxy is equals to x plus y, vxy is equals to x square plus y square. Okay, so suppose sometimes the mixed type of function can be given x plus iy plus 2x cube plus 3i x plus I. Then can you tell me what is u and what is v? If the function, complex function fz is written like this, then what is u and what is v?
X and Y, sir.
Okay, x,
U is X.
u is equals to what?
X.
U is equals to only x. Look at the function very carefully.
2x cube plus X, sir.
Exactly. 2x cube plus x. Okay, the real part. That is, you can, and v is equals to what?
3x plus 1 plus Y, sir.
Exactly. 3x plus 1 plus y. This is v. Okay, so the functions will be, this can be divided, split into two parts. One is ith part and what is the just simply real part. So real part here which is not included in I. So simply separate the ith parts and separate non-ith part. X 2x cube. These are the separated, that is non-ith part, plus iy 3ix I. So I can write it like this: 2x cube plus x non-ith part plus y plus 3x plus 1. This is the ith part. So obviously ith part is represented by v and non-ith part, that is the real part, is represented by u. uxy plus vxy. I into vxy. Okay, so a complex function is also can be written like the complex number, but remember, instead of the constant value here, the function, some functions are given of x and y. Okay, next, Cauchy-Riemann equation, and which is very important equations for to find
Excuse me, sir.
the condition for analytic function. Now, what is analytic function?
Hello. Excuse
Analytic
me.
means
Hello.
differentiable. Analytic means, remember, but within a region or within an interval. That is, suppose I am giving up an interval or giving a region, that is a function fz is analytic in within this circle. It means that at each and every point of this circle, the function fz is differentiable. That is differentiable in the multiple points within the range. Each and every point within the range, if the function is differentiable, then it is called analytic. But differentiability, it means differentiable only occurs for only one point. Suppose x equal to a or x equal to b. We have explained the differentiability in the real number case previously. Okay, differentiability means it is the function is differentiable at only one point. Analytic means the function is differentiable at each and every point within a region or within an interval. Okay, so this is the, write down this one, Cauchy-Riemann equation, very very important. That is I have just marked it as in red color. If you're done, then tell me. I will go for the example. Okay.
Excuse me, sir.
Yes.
Sir, could you just repeat that U and V part, sir? I just got disconnected. So,
Okay. Good.
just in short, sir.
Okay. A complex function, it can be represented as uxy plus I into vxy. Okay, this one like this. Uxy plus I into vxy. Ith part is that is some function. Suppose a function fx. Look at this function fz. It is given like this. Then how can you convert it to this form u and v? How to find out u and v form? Just separate the ith part and separate the non-ith part. Okay, so first we separate the ith part, non-ith part. What is non-ith part? This is not included in I. This part is not included in I. So I am separating this. And if I separate the ith part, this one, and this one. Okay. After separating,
Sir, yeah. Hello, sir.
yes,
It is just like U means real part and V means imaginary
A
part.
means imaginary part and nothing else.
That's it, sir.
That's it.
Okay, okay, sir. Okay.
Instead of points x and y, the function is given here.
Oh, okay, sir.
In general, we
Got
have
it.
write 3 plus 2i, 4 plus 3i like this. In this case, x plus y plus I into x square plus y square like this. Complex function. This becomes complex function.
Okay, sir.
Okay, now you have learned here. Yes,
Just show the 14, sir. 14, sir.
14 slide. This one.
Yeah, sir. Okay, okay. Yes, sir. Fine. Okay.
Okay. Now look at this 14th slide. CR equation. Okay, this is the CR equation. Du del u del x is equals to del v del y. It should be equal, and del u del y is equal to minus del v del x. If these two conditions are satisfied by an equation, complex equation or complex function, then we can say yes, that function is analytic. Okay, but not vice versa. If these conditions satisfied, then it is analytic. But if the function is analytic, we can't say it is always follows this rule. Not vice versa. The condition is necessary only. Next, tell me, is this function analytic or not?
Not analytic, sir.
Not analytic.
Yes, sir. Analytic, sir. Sorry. It's analytic, sir. Answer is coming same, sir. Cos x and cos h y. Del u by del x equal to del v by del y.
Okay. So what is u here? This is u and this is v. Okay, I multiplied with v, so cos x sin x, this is v and this is u. And look at this 14th slide. The equation is del u del x should be equal to del v del y. Okay, so del u del x should be equal to del v del y. Okay, and del u del y should be equal to minus of del u del x, del v del x. Okay, del u del y equal to minus del v del x. Okay, so now del u del y, u del y, so del u del y, sorry, del u del x. So del u del x is u is this one. So x means cos hyperbolic y. This is hyperbolic function. Okay. So cos hyperbolic y. There is no function of cos hyperbolic y because we are taking the derivative with respect to x only. So only sin x will be considered. So sin x means it becomes cos x, and cos hyperbolic y is just the constant term. Okay. Now del v del y. Now del v del y del y is equal to sine hyperbolic y. Sine hyperbolic y is only cos hyperbolic y. Cos x is not acceptable because we are taking derivative with respect to y. Cos x is constant. Sine hyperbolic y, the derivative is cos hyperbolic y only. So it is cos x cos hyperbolic y. Okay. So cos x cos hyperbolic y, cos x cos hyperbolic y. This equation is satisfied. Next, del u del y. So del u del y with respect to y, cos hyperbolic y. Cos hyperbolic y is the derivative is sine hyperbolic y, not minus. Remember, the derivative of, remember this one, I'm writing it with different color. Derivative of okay, do not use minus sign here. This is hyperbolic function is not like general cos x or sin x function, so that you there will be a minus sign. No. So del u del y. So y means it is sine hyperbolic y only, and sin x is a constant term. Sin x sine hyperbolic y. This is the derivative of del u del y. And next one is del v del x. Now del v del x means, okay, cos x hyperbolic y is a constant term. Cos x means minus sin x. Sin hyperbolic y. And look at this minus del v del x. So if I put minus sign here, it becomes plus. So del u del y is equal to minus del v del x. Yes, these are the same. So this equation, these and these are also same. So it is analytic. Yes. Okay.
Sir, del u del y becomes minus sin x sin hy.
No,
So
no,
cos
no,
of hyperbolic y is minus sin of hyperbolic y, na?
no, 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 no. Only sine hyperbolic.
Oh,
Check
sorry.
internet or check whatever. Only this is the difference between sine x and sine hyperbolic or cos x or hyperbolic function. In case of only x, there is no hyperbolic, then there should be a minus sign. In case of cos x, okay, ddx of cos x is equal to minus sin x. But ddx of cos hyperbolic x is only sine hyperbolic x, not minus. Okay, this is the difference. Okay, remember this one. Okay, done. Next, poles. Now, whatever the important equations. Okay, that is a very important thing, which I have found the maximum number of questions are from these poles and complex integration. Okay, so if you want to try the complex integration, you have to find out poles, you have to find out the residue. Okay, everything covered for the complex integration. The complex integration, there are many ways to solve, but I will teach you only one way by which you can solve any type of complex integration problem. Okay, and which is the residue theorem, by using the residue theorem. And if I use this theorem, then all the other type of problem to find out the poles of a function, to find out the residue of a function, okay, everything will be covered. So that is why I start with the poles. There is too many story behind the poles. Okay, poles is actually a particular type of singularities. Okay, and that should become, if you know the Lorentz series, there first you should know the Lorentz series. The principal part of the Lorentz series, the poles comes, or the essential singularities. Okay, so there is many more story behind it. I don't have the time because complex number is a very large chapter. So how to find out the poles? I will teach you a very simple method. Okay, pole means, remember, where the function, whatever, suppose fx function is given you, I am giving you fx equal to 1 by x plus x minus 1. Can you tell me what is the value of x? What is the value of x for which this function fx doesn't exist? Write down in the chat box what is the value of x for which the function fx doesn't exist. Yes, only one. If I put x equal to 1 here, then 1 by 1 minus 1, it becomes 1 by 0, and it means obviously it doesn't exist because the denominator is 0. Okay, similarly, any kind of function, if I consider the denominator term is equal to 0, that is x minus 1 equal to 0, and find the value of x equal to 1. So for this value of x, we can say that yes, this function actually doesn't exist. This value is considered to be the pole. Okay, there are too many things about it. I'm just giving you the shortcut trick to find out the pole. Okay, there is many more other method, actual method to find out the pole, Lorentz series method, which is okay, but I'm not going to say you that. Now tell me, if I consider this function z fz equal to z minus 1 by z square into sine of z minus 1, what is the pole? Please participate, everybody. Okay. So here, look at this. Yes, 0 and 1. You should consider this one. Okay, but in this case, I should mention that actually this function is from Lorentz series. So only z square term you consider here. Actually, this one it can be written as 1 by, sorry, z square. Okay. Yes, you are right that z equal, if I put z equal to 1, there is another singularity or another undefined function is there. Okay. But here in this case, consider z square equal to 0. And here you can find z equal to what? 0, comma 0. Okay, 0, comma 0. This is called pole of, so 0 is called z equal to 0 is a pole of order 2. Pole of order 2. Okay, remember if this kinds of condition occurs, not only 0 is there, you should consider here z square is equal to 0 and z is equals to 0 comma 0, and which is called a pole of order 2. Okay, very important thing it is. Pole, you have to find out the pole, and also you have to find what is the order of that pole. Next, find the of each and every order. How many poles are there and what are the orders of the of that poles? Please participate everyone. This is a very easy question. Just put denominator equal to 0. Okay, and you can easily find the poles. How many poles are there, and each and every pole has separate order. Each and every pole has separate order. There are 2 poles we can find. And what are the orders of that pole? Yes, z equal to, if I put z equal to 1, z minus 1 equal to 0, it becomes z equal to 1. Z equal to 1 is a pole of order 1. Okay, z minus 2 whole square is equal to 0. It becomes z equal to 2 comma 2, z minus 2 into z minus 2. Okay, this is z equal to 2 comma 2. 2 comma 2 means 2 is a pole of order 2. These kinds of things are very important because order and pole, not only pole, what is the order of that pole? There may be multiple pole is there, and each and every pole has different orders. Okay, remember this is very important because in the options there should be poles and there along with their orders, not only the poles. Next, residue theorem.
Sir. Hello.
Okay, what is the theorem and
Sir.
down the theorem? Until and unless I am just explaining an example, you are not getting the getting this theorem. I know. So just write it down. This is very important theorem. VVI I just written here. Okay. And you will apply only this example. There is this rule to find out the value of any complex integration. Okay, and your maximum gate questions are from complex integration. So that is why I always suggest you to apply this theorem, complex integration theorem. Sorry, residue theorem to find out the complex integration. Please tell me if you are done.
Sir.
Yes.
Hello.
Yes.
Sir, we have taken z minus 2 into z minus 2 equal to 0, sir. So
Yes.
there we have find out z equal to 2 comma 2, sir.
Yes.
Then order of Z will be 1, right, sir?
No,
Suppose
order
we
is
have
2.
taken.
You are finding two tools. Z minus 1. Sorry, which one?
Z minus 2, sir.
Z minus 2 is order 2. Pole of order 2. Because this is whole square is there. Look at this. Whole square
So
means
we can
Z
shift
minus
the
2, Z
square
minus
in
2.
to square root of 0 like that. It will be of Z minus 2 only.
No, 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 no. I know Z minus 2 only, but how many 2's I were getting? This is the definition of poles. Okay, if the power is square and you are getting two 2's, then it will be called the pole of order 2. Okay, if there is only one, that is Z minus 1 is there. Look at this, the power is 1. Z minus 1 whole to the power 1, and you are getting only 1, 1. Then it is pole of order 1. And you are getting 2, it means it is pole of order 2. Obviously, the 2 is single number, but how many times you are getting? Obviously, you are getting 2 times with this Z minus 2 and with this Z minus 2. So, this is called order 2. This is according to the definition, and obviously, this definition you will need this definition to solve the integration. If you don't follow this rule, you can't solve the integration. Okay. So you cannot change it. This is the rules or this is the
Okay.
definition according to that.
Okay.
Just excuse me. Hello, sir.
Yes.
Hello.
Yes. Hello.
Sir, will like poles and order? Yeah. Will poles and order will be different, sir, in any case?
Yes. This is poles of order may be different. Just suppose I am taking this one as z minus 3. Z minus 3 whole square. Then what it becomes? Z minus 3 whole square equal to 0. You are considering this now. So what is this? This is z equal to 3 comma. Then it becomes the pole 3 is a pole of order 2.
3
Isn't
or
it?
2.
The pole of order 2.
Yeah.
It may be different. It may be same.
Sir, which formula we have to note down, sir, from residual distance?
This formula is
Can you just highlight?
this one.
Sir, if we get a Z in terms of complex number, sir, then
Z is obviously in terms of complex number.
means like imaginary A plus IB like that.
Yes, Z is A plus IB. Z is itself A plus IB.
So then there will be order same only, sir, 2 only.
What? Hello?
Hello.
Yes, tell me.
If we get the roots like A plus IB and A minus IB, then order will be of 2 only, sir.
No, no, no. Order means same root. Okay, that is root. You are talking about the root.
Yeah.
Okay, this is not root. Okay, in case of second order equation or second degree equation, that is okay.
Yeah.
So root means if you are finding something that is suppose root and this thing is quite different. You are not finding out the root of this equation. This is just only your z equal to alpha or z equal to a. This is the real part. Each and every, you should remember that each and every real number, okay, is also a part of our imaginary number, where I part, that is imaginary part, is equal to 0. In this case, in finding a root 2 or 3, whatever we are getting, this is also a imaginary number, okay, but the part of ith part is equal to 0 there. Imaginary real number is a subset of the imaginary number. You should remember this. Okay, in this case only z minus 3 or z minus 2 is there. There you are finding out, yes, z equal to 3 or 2, yes, but this is also imaginary where the part of imaginary is 0. That is, I can write 3 plus 0 into I. It doesn't mean that z changes to real number or this z. Yes, every real number is an imaginary number. Whenever we are just concentrating on real numbers, then we are just considering the real part of the imaginary number. Whatever the algebraic method or whatever the methods we have done in the previous classes, in class 11 and 12, whatever. Okay, everything we are working on the real part of the imaginary number, not the imaginary part of the imaginary number. Okay, so in this case, if I consider z maybe as a 3 or 2, yes, this maybe is imaginary, but the real part is 0. Got my point?
Yes, sir. Okay.
Okay, write down this theorem. This you should need this one, and this m is the order. Okay, this m is the order of the pole. So I am directly first to solve an integration, complex integration. We first want to find out. We should find out the residues. Okay, and this is the residue theorem. This is the residue theorem. 1 by m minus 1 limit z tends to alpha, this one. Okay, now what are the residues? First of all, to find residues you have to find the poles. Tell me, write down in the chat box, how many poles are there and their orders. How many poles are there in this function exists, and what are the order of the poles? 6 poles. No, not 6 poles are there. 6. The order are different. Exactly. Orders are different. So how many poles? From here we are getting z equal to 1. Z equal to 1. Order is 4. Okay. Z equal to 2. The order equal to 1. Z equal to 3. Order is equals to 1. Just look at the power. Z to the power 4. It means order 4. It is 1. So order 1. It is 1. So order 1. Okay. Now we are here find the residue of fz equal to this at z equal to 1. That is, we have to find out the residue only for z equal to 1. We don't have to find out for z equal to 2. We don't have to find out for z equal to 3. So what does it mean? Residue are actually depends on the poles. That is, for each and every pole we can find each and every residue. Okay, so since in this question only z equal to 1 at this point the residue is required, so I am not bothering about z equal to 2 and z equal to 3. Now what is the order? Z equal to 1 is the pole, order is 4. So order here in this formula, the order is represented by m. So m is equals to 4 here. Look at this z1, the order is 4. So m is equals to 4. Now simply we will apply the formula. What is the formula? 1 by m minus 1. Okay, what is alpha? Alpha is the pole. So simply write down the formula here, 1 by m minus 1. So 1 by m minus 1 factorial. Okay. Limit z tends to alpha. Limit z tends to alpha. D m minus 1. M minus 1. z minus alpha whole to the power m fz. Done. Write down. Simply just put the values. Order is 4. M is represented by the order. Sorry, order is represented by m. So m is equals to 4. What is alpha? Alpha is the pole. So alpha is equals to 1 and nothing else. So 1 by 4 minus 1 factorial. Limit z tends to 1. M minus 1 is 4 means 3. Z 3. Okay. Z minus alpha. So z minus 1 whole to the power m means whole to the power 4 into fz. Fz means z cube divided by z minus 1 whole to the power 4, z minus 2 into z minus 3. Okay, this one. So z minus 4 whole to the power 4, z minus 4 whole to the power 4 is nullified, and we are getting 1 by factorial 3. 1 by factorial 3, z minus 1, so limit z tends to 1. Okay. Now third time derivative of this one. Okay. Now what is the residue? Okay. Third time of derivative of this one. This is quite large, lengthy. Okay. So I am directly putting the value here. The result is yes. The result is it is. If you can just simply just simplify this one, it becomes 1 by factorial 3. 1 by factorial 3 means 6. You can write down 6 directly. Z tends to 1, d3, dx3. Okay. If you just, okay, you can just simply do this, the fraction. Okay. As I have taught you in the last class, last to last class, I think. Okay, partial fraction. In case of Laplace transformation, so you can apply the partial fraction to for here. Okay, to it becomes z plus 5. Okay, minus 8 divided by z minus 2 and plus 27 divided by z minus 3. Okay, now you can take the derivative. Okay, so after taking the derivative, it becomes 1 by 6 limit z tends to 1. So this is z. Now taking derivative, here you can find it becomes z square, sorry, 1, it becomes 0. Okay, plus 3 times derivative of, I am directly getting the answer. Okay, you can, because it will take time. Okay, simply putting z equal to z tends to 1 in case of z. The value of z will be transferred to 1 after taking the derivative. Okay, that is z equal to 1, put z equal to 1, the limiting value of z. Okay, and here you can just put z equal to 1. So 1 by 6, if I put z equal to 1, here z equal to 1, here z equal to 1. Okay, put it and you will get the answer as derivative and putting the limiting value and nothing else. Simplification, only simplification. But in the exam, this kinds of large problem will not be there. Just to make you understand, I am explaining this large problem so that in case of a small problem, you will do this very z equal to 1. So what is the residue at z equal to 1? This is the residue at z equal to 1. Next, this is called residue theorem. Used to find the Cauchy residue theorem is used to find the complex integration, which is the most important part. Find the residue and summation of all residues into 2 pi I. It will give you the value of this integration. You don't have to integrate it. In this case, the questions will be small. Don't that large type of questions will be there. Okay, because you will not have too much times to solve
Sir,
these problems. Yes.
sir, when we are saying we got 101 by 6 residue at z is equal to 1. So what is
Yes.
the meaning of this residue? Matlab, what we are trying to say?
This is residue meaning.
Yes, sir. If you could
Residue
explain.
meaning it is a definition. Residue. If you say what is the meaning of residue, I can't say you the meaning because it doesn't have a particular type of uh, physical explanation. Okay, if you say this is a purely complex analysis type questions, and this is yes, if you want to find out some equations you are getting, okay, actually residue is necessary to find out the complex integration, these kinds of integration. Okay, and how to find out complex integration? Yes, these kinds of integration you can face these kinds of integration in any physical problem. Physical problem means in any chemistry problem or any other problem, complex function is there and complex integration is also there. So how to solve this complex integration? This is one of the technique, that is if you find the residue and if you can apply this formula, then you can find the integration. But if you say what is the meaning of it, there is no physical meaning of it. This is a definition, just like okay, because this is pure mathematics, this, like things. Okay, I cannot say any physical meaning of it. Yes, for complex number there is a geometrical representation of this integration or like this. Okay, and I don't have the time to explain this geometrical representation. Remember, there's all these things, all these integrations or whatever we have done. Okay, everything there is a complex plane or complex it is a three-dimensional things is there. It is not only 2D things. If you are going to find out this integration or something, you have to do it in 3D space. Okay, so there is some uh, explanations or some physical representation of that. Okay, but due to shortage of time I can't give you. There is a particular software where I can also explain that physical representation or geometrical interpretation of that. Okay, but in physical means in real life problem, you cannot directly this residue is related to any physical or real life problem. Okay, what is the necessity to find out this integration residue is necessary? And what is integration is necessary? Yes, integration you will find to solve any physical problem. Integration, this is a physical representation of this. So residue is a pure mathematical things. I can't just picturize you these things. Okay, it is a definition you should remember. Any Hello?
Yes, sir. No doubt, sir.
Okay. So remember, this is only z equal to 1. The residue can be found. Only for z equal to 1. Still, there are two other poles. Okay. What are the poles? The poles are just, can you tell me the poles, other poles? Z equal to 2 and 3, I think. Okay.
Yes, sir.
Yes,
I just cleaned the equation. So, yes, z equal to 2 and 3. So for z equal to 2, you can get another residue by applying the same theorem. For z equal to 3, you can get another residue for z equal to 3. So, 3 residues will be there for 3 poles. For z equal to 1, for z equal to 2, and for z equal to 3. Now, come to the equation, that is this integration. And whatever the residues, now if suppose this integration, the complex function which I have given to you, I think the complex function is like this: z cube divided by z minus 1 whole to the power 4 z minus 2 and z minus 3. Okay, so 3 poles are there: z equal to 1, z equal to 2, and z equal to 3. For z equal to 1, you have got a residue 101 by 6 or whatever. For z equal to 2, you will get another residue. Okay, suppose it is b. For z equal to 3, you should get another residue, suppose it is 3. Now, if there is an integration, then how to solve this integration? The integration is 2 pi I into R1 means residue 1, this one, plus R2 means this one, plus R3 means this one. This is the formula by which you can find the integration. So you don't have to apply any other formula or other things to find out the integration. After finding the residue, apply this formula, you can find the integration. Okay, this is the real thing. So integration, there is, I have another problem of integration. This is the problem of integration, but there is only one problem left. I will discuss this problem in the next day because it is almost 8. Okay, so any doubt or any question? There is a lot of things of the in complex number chapter, a lot of huge things. Okay, it is very difficult, or actually cannot be possible to complete the whole complex chapter, okay, within just 2 hours. Okay, but still I'm trying, according to the get questions, whatever the get questions I have seen in your last previous questions, there is very less number of complex number questions. Okay, and whatever the questions I have found mainly are from this poles, residue, and this complex integration chapter. Okay, so that is why I am concentrating on this formula. That is, after finding out the pole, you can easily find out the integration. There are a lot of other rules. There are a lot of other theorems in complex integration, in complex number. Okay, so you can solve this integration by other rules also. Many methods are there. Cauchy's theorem. Okay. Okay, but I don't have the time to solve everything. Okay, if you do not have any queries, then I am ending this session now, and I will discuss about this residue the next day. And in the next day, there is only one chapter is left, which is probability. Okay, so in the last class,